going to join soon. Today's topic is going to be chapter 11, which is regular expression. The nice thing about regular expression is you learn it once and you use it on all programming language that you know and all operating system that you know. Even though on different operating system, it works differently depending on the syntax of the operating system. For example, on a UNIX, Linux machine, you might use a regular expression with grep, which stands for Generalized Regular Expression Parser, grep command, and then also the global fgrep, which is for the fixed string commands, and then also the egrep, which is multiple extended version of a grep. We will discuss those ones when we go to the demo of the Unix Linux, but a grep command equivalent on Windows is a find command. So you could search for a regular expression within a string with a find. But in order to understand with Python what a regular expression is, basically regular expression is a module, is an extension of C language module that was written entirely in C. So the engine of regular expression is in pure C. That's why it's fast and efficient. And then Python has a lot of extension and then Z lab and maybe regular expression, and there's a lot of other ones that we will use, like NumPy and other ones that could be added on to Python. It's already added on, but we are using them. And then regular expression in general, if you learn it, when I say you learn it in one programming language like Python or C or C++ or JavaScript, or anything that you are using, Perl, Python, those programming languages, once you learn the regular expression in one, you master it, and then you could start coding it in every other programming language the same way. So if you go to, and by default, when you import regular expression, if I just do a help on regular expression module, it shows that this is a module. And then the supported regular expression, RE, is kind of like an abbreviation for it. And then everywhere on the documentation, when they refer to RE, they're talking about regular expression. And then regular expression basically is a C extension module that was added on Python. And it has a lot of meta characters. It's almost its own small language by itself. It is not almost, it is a small language by itself. By defining these meta characters, you are basically manipulating a string within another string, a pattern you're searching for within a string. So whenever you're working with data text IO, every time when you're working on a Python file or you're working on a Python string or a kind of like the data structure that is a string, you're manipulating it, you're just trying to look for certain things. So for example, if you're looking for inside a file, you open the file, you say, I want to know how many words are in there. I want to know how many characters are there. I want to count a certain number of strings in there. I want to just replace certain string. All of those data manipulation that you're doing, or data extraction or data parsing, scanning the file, it is done with regular expression, much easier than just a regular Python script. A regular Python script is going to be a lot slower if you have to do it, but with regular expression, because it's written, the engine is written in C, the small kind of programming that was already built in the RE module, regular expression module, that is so fast and so efficient, that helps you. For example, one of the meta characters is dot. This meta character dot represents any character that is except the new line, and there and on the system. This encore is starting with. any character that it starts with. For example, you're looking for the match. If you're looking for this string, match is the first start with. So if you put the encore in front of matches and then put matches, then this string will be found on your search. So we will go through the methods of how Python is going to use the meta character patterns against a string, and then what methods are available to it. So the encore, for example, is the first character matching. And then the $sign, the last character, the new line character. So whatever is at the end of the line, like here, the G is, after the G is a new line character, this $sign matches that. So if you're looking for a string, the word string that ends with $sign, you could do a meta character, put in front of the $sign, a string, and then ends with $sign. That means, yeah, this result will match true. And then the star, this is kind of like there's qualifiers and regular expression. Some of the qualifiers are like star, plus, and question mark. Each one of them has different meaning. A star means 0 or more. It's meaning that this is greedy. That means if it find a 0, it matches, and if it will find maximum of as many as it is available. This is so if this is better in a way. Plus means 1 or more. 1 or more is that sometimes in your search you don't have to. I mean, you have to have at least 1. Or a maximum of 10 or 20, whatever the maximum is, doesn't matter. But if it searches at least 1 existence, then you use the plus. If it's 0, this is like wildcard. A wildcard is also used on UNIX programming and Windows operating system. So sometimes you do a directory star.txt, it matches everything. Directory star.py, you will do this one, or ls-l star.py, you will see on Unix. So the question mark is that match 0 or 1. This is going to be optional, like it either matches 0, it does not find anything, or 1 maximum. So it's opposed to the star and plus, because they are greedy and then they can go more than that. And then this is the quantifier. The minimum M and N is the smallest one starts with M, and maximum starts with N. So the braces is the qualifier in this case, is how much of your pattern should be matching. So if you have 2, 5, meaning that it has to have at least 2 of that match, whatever you put on the left side of this, and then a maximum of that. And then this is also to make it non-greedy. So it could have an option of 0 or more. Like for example, when you search on a URL with HTTPS, so if you put HTTPS here and then put question mark after that one, you don't have to put the qualifier. You could look for HTTPS, and then if it finds HTTP, it will work. And if S is the last one with the question mark, it will just also work if it found HTTPS. This one is a backslash. Basically, a backslash in Python is already a escape sequence that you could just say backslash ends, backslash tab, backslash T for tab, and backslash F for form feed, and backslash R for cache return. Whatever you're doing backslash, sometimes the character you could backslash it, or another digit you could backslash it, or another special character. So all of these meta characters that we're listing here, sometimes you just want to search for the meta character, for example, for a plus, for a dot, for a $sign. Then you have to skip them with backslash. And then some of these characters like this or, the bitwise or, so when you say if it is found uppercase A or uppercase B, then it's a match. When you can do this Boolean kind of condition for two strings, you use this bitwise or. But then if you use this bitwise or inside of this class, which is the left bracket and right bracket, then you have to put any special character like $, at, and left bracket, parentheses, right parentheses. Any of them, when you put it inside this bracket, which is a class or a group of, a class of either a class of lowercase variables or uppercase or digit, any other character matching that you're doing it. When you're doing inside these ones, you have to skip it. For example, if you use the bar will not be recognized, or the encore will not be. Encore will be always like this one is the first of the character. When you put inside this one, it is negating it. And so I'll show you some of the examples when we go to the actual demo of Python programs there. And then the grouping, sometimes you group it so you can just look for certain groups. And then the search that you do, if you group them, and you can just sometimes pick up from the first group or second group or third group. Sometimes you can even name them by groups, and you could pull the data from the groups. And some of the methods that are there, like find all, does not support grouping. So what you do normally, you assign them to a list or a tuple and then manipulate it that way with a for statement. But like a search, a method has the grouping. You could search, and then after that one you can group and those ones. I'll show you some of the examples as well there. And then these are all options of what you can do with the grouping, and sometimes you can name the group and everything else. like this one, question mark uppercase P is equal name. This one is just creating a name. So then you can say print the group name. Sometimes you can use the group printed by a placeholder. Sometimes you don't. I mean, depending on what whether you create a name group or not. So some of the meta characters here with backslash, for example, it matches only a start a string, and then matches only at the end of the string. And some of them are like spaces. And then this is any digit. And then the absent of any digit would be uppercase D. And then the absent of any space would be uppercase S. So like this /S, check for a tab / new line, carriage return, form feed, and vertical lines, vertical kind of like columns. So and the absent of that one would be uppercase S or encore of this, negate of that lowercase. And then you can see like this one /W searches for any word, any characters. Any character, this would be any lowercase alphabet A through Z, and this is equivalent to this. So you could say either write a short form of it, /W, and then search for that pattern to match any character between A to Z, or uppercase A through Z, or any digit 0 through 9, or underscore. Underscore is also found here. And then the absence of that one is, sorry, let me move this one back. And the absence of that one would be the uppercase W, which is going to do the opposite of these, anything but these characters. And that would match. And this one is just a skip of literal backslash. And then these are the functions that we will be exploring mostly today. The match function, the full match, search, substitute, sub-n, and split, and find all, find iteration, and so on, purge and escape. So we will do those ones. In addition, that for every of those functions, there's 2 or 3 flags The first flag is the pattern. The second, I'm sorry, parameters. The first parameter is the pattern. The second parameter is the string that you're searching for those methods. And then the third one is the flag. The flag, sometimes you say, for example, escape the case, ignore the case. So like you could put an I on the flag or just type in the whole word, ignore case. So abbreviation would be I, for locale would be L, for multi-line is M. And then S, for example, for dot all. This one, for example, if you're doing the dot, remember the dot operator, the dot made a character was matching any character except the new line. So if you want to just include the new line, then on your flag, you could just say right here, either put as a third argument, flag is equal S, or just put dot all. Dot all means include the dot and everything else, and a new line also. And as you can see here, it explains it. And then something like ASCII characters and multi-lines, all of the Unicodes, everything is all in the flags that are there. So some of the function class match on the Python that are available are here listed. Some of these ones are on a lot of the method that we already looked at, for the string, for list, for tuples. Some of them are available as well. Like for example, you could copy a list to another list, or a tuple to another tuple, or something like rep or representative of equivalent to like a string. And then there's end and expand and start. All of those ones comes with the search, the match character that you're searching, and how you generate it. I'll show you these examples of expand and end and start, and how we can do group and groups, and then groups dictionary, for example. Sometimes you are picking up certain data, and then at this time it's only the data that you're picking up as key pair value. So you can get the group dictionary, and then from the keys, now you can get the values from it. This groups is also available, similar to group. Groups and group are doing the same thing. Inside this group, you can put a group name with a string, or you could put a group, a number, like 0 represent the entire group. 1 means the first group, and the second means the third group. If you just leave it blank, by default, it assumes group 0. And then start and end, and this is also when you do the match, sometimes you want to just get the indices of those match, so you can search for it. Last group, last index, regular expression. So we went through a lot of these ones, greater than, less than, equal, already with some of the other data structure. We compared, you can compare, like for example, if some item is less than the value that you're looking. So whatever is the object, if it is less data structure or anything, you could do a less than or not equal to, and those kind of things you can do there with them. The find all, I have a lot of examples. I have about 15 or 17 different examples with regular expression that I put it in a Word doc, PDF document, as well as the module. I'll show you that one later, and I'll go through each one of them with you. The find iteration is another method that you could do with the re.compile, and then go through iteration in each one of them. And you could do the full match, scanner, search. We will go a number of these examples, split, substitute, and then so on. So these are the functions that are available. And then the variables with regular expression is basically very fast, very efficient. And the nice things about what I showed you there with all these information, the functions, yes, on different programming language may have different names and different methods and different objects, different parameters. However, the idea is very similar. The fact that we understand, like for example, on top, these meta characters, no matter what programming language you use, what operating system you use, once you learn it once, then you don't have to worry about it. You could apply it to Perl, Python, JavaScript, C, C++, whatever programming language that supports regular expression, it will be the same on these meta characters. And these slash S would be nearline characters, and this slash uppercase D would be non-digit, and then slash D any digit or any numbers between 0 and 9. So it will be the same on the programming language. That's a very, very universal. And then since it's written in C, again, it's much, much efficient and fast. And Python use it there. So re.compile is also, sometimes you want to compile the pattern ahead of time, so you could do a little bit more efficiency, and as well as just check to your pattern to make sure that the value print is coming from what you want. Sometimes with the pattern, you could just use the regular pattern. Sometimes you use the R method, R string, which is the raw, and then that way you can control it that way too. So here, as you can see on this documentation, I highlighted everything that are functions with boldface, so you can read it and then understand, for example, what the escape method does, or what is the match string does, and purge and so on. So you can see the function and then the explanation there. The other thing is with the flags here, there's more than just a few flags that was listed earlier. So RE, regular expression dot ASCII, or A, when you put it on the flag, so /W will check for all words, but sometimes you want to do more restricted version of ASCII characters, then you could put as your flag as re.ascii, and then it will check for those kind of characters only, ASCII characters. In case if there's some Unicode or some other characters, you want to restrict it to only ASCII characters. On your flag, you put re.ascii. And then the other options are there too. Like sometimes you search for test, and the word test is found, but then you say whether the test is written in uppercase T or uppercase E, or the entire thing is uppercase, or one character is uppercase, or 3 characters uppercase. I want to match all of them. Then you can do ignore case. So on the UNIX, for example, when you do a grep, you do a grep minus I. Minus I means ignore case. On Windows, when you do a find /I means find a string with ignoring the case. I could show you those examples as well when we go through the examples. So this is the entire regular expression Python module, and it even shows you on Windows what is the re.py script. So if you open this one, this is the actual source code of the regular expression that was written in C, but it is .py extension. So you open it up and you can see further details of it, which is on mine, is on the Anaconda distribution there. So this was just basically the regular expression, but then there's another guide, regular expression, quick guides. This quick guide actually is the same meta character that I just explained, but I made it in a very kind of like quick guide for you, so you don't have to do all of that one, but you need to know at least these ones. So this is not a bigger list. You can see that it's there. The first character that you're searching, if something matches at the beginning, use the encore. If something matches at the end, use the $. If matches any character but not the new line, and then a space, any white space, and then any non-white space. This is repeat 0 or more times. This is optional, that you say matches but the non-greedy options. And then this one is one or more times. This one is basically non-greedy again with repeat the characters one or more times, but non-greedy. This one is 0 or more times, but non-greedy. Let me move this thing here somehow. I'm gonna resize this one here, sorry. And then, okay, so that's good enough. We can see it. And then this is the class. You can classify, like, for example, this is all A, E, I, O, U, any vowel sounds that you want to just make sure that you search for those ones, you could put in there. And then you wrote some Python script to search for those ones. You can put it in a list, but notice that a list is also like start with the left bracket and right bracket. But then this one, when you're putting in a pattern for regular expression, this is considered as a regular expression pattern for that module. It is not considered as a list. Or sometimes when you use the left parentheses, right parentheses, when you're using inside the regular expression, this is not a tuple. This is a grouping. So the syntax of it depends on what environment, on what context you're using it, and it means different things. This is like for not an uppercase X, not an uppercase Y, or not an uppercase Z match for that one. This encore, when you're putting inside the class, it negates it. So this one is searching for any character that are lowercase a through Z, or any character between 0 to 9, or any digit between 0 to 9. So if you put an uppercase A, this will not match. An uppercase Z will not match. 10 will match because 10 is between, 1 is between 0 to 9, and 0 is also between 9. But since 10 is 2-digit, this one only matches 1 digit. So a 10, a 1 will be matched, but 0 is not. So if you just search for a 1, it will match. But if a 10 is next to it, then you have to put, like here, a star, meaning that 0 or more characters. And then, or plus, meaning 1 or more of that digit. So you have to put a qualifier. And like you could put braces here with a comma, 2 of them, then that would search for this kind of match with 2 consecutive numbers there. So this is the shortest one. This is for grouping. The qualifier is not showing here, but the qualifier is, I mentioned it, is the braces. Inside you could put M, N, and that one is the first number that finds it to the maximum. And then right here, I have an input file called infile.txt. The infile.txt basically has a number of sections of information in the file, so I could do different examples. First, this starts with some strings with 2 lines. Then it has example of URLs listed, like for example, pasadena.edu, canvas.pasadena.edu, google.com, nasa.gov, and gpl.nasa.gov, oracle.com, our unix.com, and then I'm putting for our unix.com a port 8080 because I'm running it locally. So this is my website for just teaching Unix and writing documentation of Unix manuals and coming online with a lot of stuff, and that is not available on the internet. So I want to show you one thing here. For example, our unix.com port 80. If I just cut and paste this one is available on my local network, but not available outside currently. So this one is basically like a book that I wrote on Unix Solaris. It's called The Direct Way to Solaris Express. And this is just the cover of the book. It shows you what is covering on this book. But if it has like a number of chapters on it. I want to show you a couple of things. Like for example, if you go to each example, it shows you in details of what it is, and then if you need documentation, I have these other ones that I'll show you. But what is nice about this one is that, like for example, let's say on chapter 2, I want to show you, if I go to this chapter 3, and then it goes more extensively, like this one, look at this one is about maybe 120 different commands. Each one of them, they take arguments. So when you go to the arguments, you can run the command, and then you're on a browser, but you're running these commands on Unix operating system. So it will just run, and then it will execute it. But the reason I'm showing you this is because originally I wrote this one in Perl, then I converted this one in Python, and now in the Python, I have to write the same CGI scripts that are there to do a lot of regular expression. A lot of regular expression, for example, creating demand pages, running these commands, and parsing the argument that are there. For example, let's say somebody clicks on the cat, then I list them what they can do with a cat. Cat -n on Unix, it looks at etc network. It will basically run this command on my operating system and will print out the result here. But if I did not know how to do regular expression, all of these commands would have not worked. For example, let's say I do here, I go with regular expression, and then I just want to modify this one, say cut -n, and then plus etc host file. So now I just changed the host file. I want to do this one. If I just say, okay, let's just do is equal cmd is equal ls -l. So now I run this one, it runs the output of command. If I want to change this one, basically I'm sitting in front of a browser, I'm able to type in Unix command and execute it. So if I just say grep -i, let's say I will just do something here, cat etc host, and then plus, and then grep pipe it, and then grep -i. Let's see if I could just say 127. So if I could just look, yeah. So this command, actually, I run in my etc host, and I knew that there's a string called 127 because it's the local host IP address, and then I could just grep it. But notice that this is URL encoded. URL encoded is putting all the percentage 20 to spaces, is changed to percentage 20, and then additional argument that I'm putting is taking as a key pair value of argument. But my Python script, which in this case is solcmd.cgi, it takes this information, then I parse it and then run it. So if I just run here a different command, like pwd, it prints my working directory there. If I type in uname -a, and then I see that what is the operating system, I could get that one. And then remember, we were typing like cut etc os-release. Since this is a Solaris machine, you can get that information here. So I'm sitting on a browser, but I'm executing on a Unix server, and I'm getting the data back to my browser. So that is the powerful of programming with Python, with CGI scripting, with regular expression. All of that one is coming into play as an application. If you want to see an application of it, this is something good. So let's say right now I'm going to show you the part that is in the progress. So if I do a man and then I say pwd, for example, print working directory. So look at this, it comes out this, but because the man itself, it has a lot of the encoding kind of like strings that are different that I have to do on the parsing of my Python script, then I have to convert all of these characters that are non-ASCII characters or special characters that are not recognized. I have to change all of them to do that. And to show you that one, for example, this is before, and then if I go to our unix.com/cgi /man pages, this one is after. So like here, the same manual pages that I was just showing you, I have like all that one in a document written. So whether you're working on Unix, Darwin, or Linux, or Solaris, or Windows, or PowerShell, I have done all of them. And then all of this one is also an alphabetical order. You can get it for Darwin, A through Z, and then for Solaris, and so on. So if you could just click, for example, on Solaris, the one that we were looking at, there's thousands of documentations. On Solaris, just it's about 13,000 documents that are available there. And then all the users, they could go and say, oh, I'm interested in some commands here. They could just click on it, and then I'll just generate the man page for it. And then it will give him the man page and then in nice format, because I actually parsed it. With the other command that we were looking here for the man page, it was not. Now here, let's say I come in on this one and I say, okay, I got it that you have sorted. Let me get the sorting commands. For example, here we did the PWD. So I'm going to do the equivalent of it and look for the Solaris. This is Solaris. So PWD would be under P. So I search for this one. Then right here, there's a lot of them. In order to find out exactly, I could do PWD, and then it's going to find that command. So it's going to do this, PWD. And nice format is printed and everything. You can read it through this. If you say, how about PWDX for executable? This one print working directory of executable, the path of the script that you are doing it. So this is all under the proc file system. I taught a class with Unix bash scripting, but I had written this one about 10 years ago, and then I'm still modifying a lot of things here, because what I want to do is right here, you could do the same regular expression that is there, whether it's this or that. You could go with any operating system, like here with PowerShell. You can see that the PowerShell is also there. So any thing that you want to learn about PowerShell, you're welcome to use this one. For example, let's say update a script. You could do that one and you just read it. And then the nice thing about these documentation, sometimes they give you examples and you can try the examples as well. Or if you're interested in Windows, this is about 120 commands, and this is much easier. You could do this one, but notice that these are all already with my script. I already took care of it, and then they are coming with nice format, but by doing a regular expression there. So I could do the same thing here with this script and modify it, and then just the next time you will see it, it will be in nice format printed out here. Let me show you one more thing here before. So this is the application of it. If you say, well, it's nice to learn Python, it's nice to learn regular expression, but where do I apply it? For example, I learned that one. I applied it making a nice website and then creating it, and this documentation is free for everybody to learn. Right now, because of my network, I'm just having it locally. Unfortunately, a lot of the documentation, when you're generating online, you have to have the same operating system available on the thing. So you cannot web host it on multiple platforms. It would be too time consuming, too much paperwork, and too costly. And so what I do is create virtual machine and do it. Once I get it configured with the network, that would be available there everywhere. So you could do this one for Linux, and then the same thing with Linux, everything is there. And then if you're looking, for example, with Python, you could do a Control F Python. And so everything that are related with Python, you could find it, or you could just go here. And so there's two match found here with Linux. One is the analysis, and then what is the next one? And this next one is, so let me just go back here. I want to, so under, let's say this one is Darwin, Solaris. What else we have? Linux. We could go on the, let's say for Solaris, under the P for Python, and then Control F and search for Python. Okay, so it's under uppercase P maybe. Python is, this is Solaris, and then uppercase P. Darwin, Solaris, uppercase P is right here. 06, it's not listed. Let me check one more thing. Under Linux manual. Let me check under the Darwin P. Python. So Python here is there. Python W is also this listed, and you can read the Python documentation here. So this is basically some tools that could help us get to the documentation, but there's a lot of documentation out there if you're interested. So this is the end file that we are going to use for parsing some of the information. So if you're looking for the phone numbers, there's a section for it. The glossary of terms are there. We can search for a string or something. Like grep command is a UNIX command that we just used on the browser, an example of it to search for 127. You could do that one also on the command lines. So here, if I just clear my screen and then type directory here. Now type host is there. So if I'm looking for our unix.com here and then say type host, it will just display it. But then if I just do, let me resize this one so it is better on that sense that you could see it the way I see it. Okay, so if I look at this file, it is showing, but then what if I'm only interested in our unix.com? Then find slash, and then I have to put this one in a regular expression, kind of a string that say I'm looking for this string. So this one, the find command is equivalent to a grep command on a Unix machine. So I could search for 192 and it will put two of these ones. And then if I just search for a string that is between 0 through 9, 0 through 9, this will just not display anything. But if I put this greedy things, it did not find anything. Let's say if I just say the asterisk, it will not find anything because the find command itself is not searching for that kind of string. So all I could do is if I look for 9, it will find it because it is saying that, okay, this wildcard is, I mean, the syntax of the regular expression is has to be supported by this find command. So this one was not supported, but I will show you the same thing on Unix machine, and you could see that it is supported bitwise with grep command. So let me log into that machine. And this one is a Linux machine. So if I just say cat etc host, it will just show me that thing. Now, if I do a grep for it, grep -i for ignore, I could say 127, it will just show me that one. I could search for the matching of similar to 0 through 9, and then see what it finds there. You could see that it already said that, okay, you're looking for a digit that starts with between 0 through 9, any of the digits that are found there. So if I'm interested on saying followed by another digit, I could put a qualifier here and say 2 digit has to be there, maximum of it there. So then that was not finding it. But if I just say 0 to a maximum of anything, it will just not match again. Plus will not match, and then a star will not match. The reason is that because I'm not going through that list. So if I'm looking for specifically one with plus, and then that is grep -i, and then let's go to 1. Sorry, this one has to close that way. And notice that now I'm going to do the actual digit. Actual digit, it's not finding it. Grep -i. So cat etc host. Let me do something here. Grep -i. If I just search for host, it will find, and then the word host. But if I put n for line number, it will give me the line number as it finds it. Clear the screen and there. So what I want to do is here, I want to show you a couple of differences between different OS. So let me open up VirtualBox here. And then at the same time, here right now, I'm using the -i with n, and n shows you the line number. But then if I just do a C for count, it will say 5 lines matched there. If I look for host itself, is still matches those 2 characters, so that would also match there, and then all of that. So let's say inside here on this file, do I have anything in uppercase? I don't, but I could have uppercase on etc network, for example, that etc networks. Yeah, copyright. So I could do a grep for the word copyright, copy, and that would check it. Now, if I just say, show me everything but the copyright, then -v. Now on this one, -v, it just says, this is my regular expression, but my v is just saying that match anything but none. And these are all operating system commands. So let's see if I just do -i and then put character A through Z here to see if it finds. Yeah, so in this case A through Z is found, and then if I say the A through Z but OPY, because that one is the copy, then the C is found here, and this regular expression OPY was found there. So the other example I was doing earlier, I could do the same thing here with etc host like this one. Since it is a digit, I was looking for 127. Yeah, so if I want to just get it with a digit, I could do here, say grep the digits 0 through 9, which would match that one. But I want to interested only on 127. So if I'm doing this one, 27 there, it will pick up those two digits. And if I just say 0 through 9, followed by another 0 through 9, followed by another 0 through 9, that would be also taking that 0 through 9. Also would be finding any 3-digit characters that are coming. But if I'm only interested in 127, I could put here also like this, that say a combination of those three would pick it up. So the regular expression, I could parse it however I want to do it, 0 through 9, followed by 1 to 3-digit, 0 or 1 digit. It's not getting it that way. Let me try it this way. And then go to 2-digit. And this is not picking up. Yeah, so the combination of this has to be with the number of digits that you're doing here, 0 through 9. I could do /D and then plus. That would pick it up if it is. This is a supporting regular expression. The /D plus would pick it up. So let's see, this D is picking up the digits here, and then /W would pick up, sorry, /W would pick up that, and then would be there. And then I could do grep minus I, let's say 47. So I could pick up the particular one I want to do it within this matching this. There's many ways you can do that one. Let me start off with Linux machine here as well, and then we can just practice those ones. So the examples on the documentation here that we're having is going to help us read these files, and then for each one of them, I have these 14 regular expression example plus 4 more, that's about 17 or 18 scripts. Altogether 19 it shows there, but because the first one is just empty, so a total of 19 files are showing. This one, what I'm saying empty is like this. So if I'm looking at the directory here, this count that it shows here, it shows 5 files, and that's 1, 2, 3, 4, 5. These other 2 directories are there. It's not going to show. It says 2 directory for them. On Unix, when you do a listing of files, clear the screen, and then do a ls-l, notice that it shows total 17, but it's not 17 files because inside these directories are there. So if I just do ls-l grep -v, grep out the total, and this will just give me everything. So I want to do a word count on this one, word count -n, it's going to be 5 of them. So if I go to Python directory and clear my screen and then do a ls-l new dir, and let's say, and there's nothing here. This is, what machine is this? Okay, let me log into this other machine. 192.168.254.10. So right now I'm logging into my Linux machine and then go to Python directory, clear screen, pwd ls-l. Now you see there's a lot of files here. So clear screen ls-l star.py, wildcard star.py, it shows all the files with the star.py. In Windows, the same thing. So if I'm like going back to Wahid, I'm sorry, users, and then Wahid, cd to Pasadena, cd to fall. Let me resize this window to bigger. Somehow changed. Okay, so cd to star file, and then notice I'm using the wildcard to go to this directory. So I could type in L star. That is also operating system allows it to type in the wildcard, and then just the rest of them. As long as this character with anything makes it unique, so I cannot type in CD7 star. If I'm outside of this directory, notice there's 27. I cannot do CD7 star. This is not gonna understand it because I meant to do it here. It just found the first one, it automatically did it. So it is not good. And then what I want to do is CD77, then a star, that would take me to that one. Or I could do CD7 and then press tab, automatically complete it for me, saying that this is what you want. So in this case, I want to go to lecture star, that takes me there. Now on the directory here, so if I go to chapter 11 star, notice that star.py also lists everything with that .py. If I look at star.txt, it only give me the text files. And a star.star will give me everything. Also a star by itself will give me everything. So now if I just say directory star.py and then pipe it and say find /i and then look for anything with .py, I could also get the same list with that way. So this search or string manipulation within another one, they call it piping. One argument pass into the other argument, as the first argument has become the input of the second argument, and so on. So if I go back here and then look at the list of the star.py, I want to see how many are there. Word count, you see 33. But if I do this one and then do a grep minus v total, so I don't get the total and the total, and then the list of it, and there it's actually 33 here, because on the top I see that total is there. So it does manipulate it in a way that I'm looking for only .py, because when I do the star.py, it already grep out the total out. But if I just do a star, then now it has everything, including the total. You can see that on the top, it is showing there. So if I do, this is a bigger list. Let me, yeah, right here, you can see, clear the screen. If you see pwd, and look at this one, it has a total of 244. This is not total of 244 for this directory, is for everything. So like here, if I just do a list minus L and then do a word count minus L, it shows 25. But if I do grep minus V total, and then because I don't want this total here, then it should show 24 of them. Because from here, Apache to the end, there's 24. So this is not a file. This is just, when you do a list minus L, it shows that, and then this becomes the argument to this command, and then that becomes the argument to that command, so it is there. In Python, when you write a function, you're just basically searching within the strings. So let's go back to Python now here and show you some of the examples. So the first example, what we are doing here, we're writing a documentation for it here as well. So Python, and then import a regular expression with open, using the with open, and this is a context manager. It opens the file input file called endfile.txt as file handle. So now I have a file handle which has a handle on it to read each line. Then I can go for line and file handle, and then with every line I could do certain things. As you can see, the right strip, it basically get rid of the a new line character at the end of the line, or stripes the kind of whatever is the last character, it stripes that one from it. Usually on the right side is the new line character. So it puts it on the line. Then I'm going to use the regular expression search method to look for the word from. Since it's an infile.txt, and infile.txt had a lot of from here section, which was like all these ones. If I look for the from with uppercase F, it should match all of these, not this one because these ones are lowercase. So when you do that one, if you look at the search here, it's going to search for that one, and if it finds it in the line, then print the line. So let's look at the example here, and we run it already here, and then the example, as you can see, it print all those ones with uppercase from, including this one. It doesn't have to start with the beginning because I did not have a encore in front of this to say match only the first of it. If I modify it with only this, it will do it. So let's just go and add them, and then we could practice that one also there. CMD, and then we basically, I already have some CMD here. So here I'm going to go add them, and then this one, I could be any other directory. So I'm going to go to Pasadena. Let's see. Okay, users, Wahid, and then Pasadena. CD to store file, store lectures / store 11 store. So this one take me to all the directory there. And then the first example that we wanted to show was example 1, which was this. So if I open it in Atom and then go to example 1 right here, regular expression example 1. Let me close these other ones because you want to see the screen only to the one that we want to open. Okay, so I want to open only this one. And this one, as you can see, if I run it, just save it here again one time to make sure it is the other ones are not in active. So we want to run this one, and what it does is import the regular expression. In order to use the search method, you have to import the regular expression. So in this case, we search for it, and let's just run it one more time to see what happened. The output should show. So here it shows that it finished. Let me see what is the reason. Python regular expression _1.py. When you run it here, you get the output. On Python here, Pycharm, I mean, Atom, I don't like it in some ways. It just does not show the output right away. And run a script and stop script, configure run a script. Okay, let me try this one with this character. I'm going to modify it here, and then now it says it has to start with the first character as F, because this one, as you can see, the output is matching also this. So if I want to eliminate this as a test from, and I only want to get this one, I put the regular expression with that. Now notice that this part is not listed. And the reason is because of, if I do a more on it, it is just have this encore. It says it start with this one. So if I want to just say, for example, the output of this one, I'm sorry, the output of this one that is there, and I say it has to start with .edu or .com. Let's say I want to see .com on it. Then I could just say from, and then whatever is character after it, you could do that one, say dot star, and then I have to have com, and then com, and then dollar sign. So it has to end with a com. Let's see if we save it and then run it here again. And notice that this time, because the way I wrote the script here, if I look at the script itself with more, you can see that I added a star. Dot star means everything else followed by the from. So I just picked up from, and then I said, okay, after from there's a colon, but then I have to make sure that the rest of the string is matched. The rest of the string is matched, and so right here to here to here is this dot star. Dot means any characters, and then a star means 0 or more of that one. And then .com is going to just do that com and then end it with a dollar sign. So if I change that one to .edu, and then say save it, and run it. Now this time we'll run with .edus listed. Notice that if I just take this star asterisk out and just leave it like that, it says that, okay, this is not going to match anything because that is space afterward and then the from, now I have a gap in there saying that it starts with this one, but I don't care what is the rest of them, and then it has to end with that one. So I'm not instructing the program to find the string. It should not find it. Let's see if it does anything different than what I'm saying. So right here, it did not find it because I did not instruct it with a regular expression. So the syntax of the search method is that it looks for a pattern inside of a string. And then if you have a comma, then a flag for it. So in this case, the pattern, I modify the pattern to just match that one. So if I put kind of like a .edu, if I take this one out and say it has to end with a .edu, this is not going to find it either. Let's see, I run it here and say this. So this one found it actually because the .edu matched all of the ones that are there. So all of the one that ended with the .edu found it. But the reason I say it's not going to find it because I did not do a dot representing as escape sequence. But in this case, it found it. Let's see if I just skip the dot, it should find it. Maybe it works the other way around in this case. So let's see. Yeah, so the accurate one is the dot there, skipping it. So in this case, because when you do a dot here, it dot matches any character, still it finds it. So let's say I'm looking for only one of them, and then say I'm looking for something that ends with I before edu. So then I could say something like here, I, and then dot edu, that would search for data string, a script, run it. And then here, notice that it does print out the output that I'm looking for, but I'm gonna show you here because it's bigger. So right here, you can see it found that one with the .edu, anything that matched that one. So this is some examples here. Let me just go back to the from here with the first example. We had this one. And then go back to the second example. Let me see how we're doing at the time, 8:23. Do you guys have any questions so far? Okay, 10 people, 9 with 10. Okay, so with me 10. So now I'm going to go with the second example. The second example, I created a pattern. And the variable pattern, now I can manipulate the pattern whatever I want to, and then run it against that one. But instead of search, I'm using the find all method. The search was finding it with multiple lists, as well as the find all is also gonna find with multiple lists. And the only difference is that certain ones like match will only match one. Search will look at the first occurrence of the list, and find all will search will actually search anywhere in the string. Like you could see the .edu was matched there, and then somewhere else was matched there. So whether the start or the beginning or the end, it does not matter. But match, and the match is only like if I go back here and I just say change the search to a match method, this will not match because this will match, from will match. Notice that if I run this one and then run this package here, so now from is matched, but if I change this one to .edu, .edu, and look at the search method and compare it, because in this example, match was not showing anything, because what happened was that .edu is not at the start, but the from was at the start. So if I just say it starts with a from, this also will match the first character. So let's see a package, run. Yeah, so if you're using match, you have to put this anchor to do that one. But if you just do this one from, and since it's matching there, it will still find it with match. Okay, so let's say I run it here. This from is already matched, but .edu, for example, in .edu, I have to put this $sign with match to say ends with this one. So let's see if it does find it. Okay, so because the match, we're only looking for what is found on the first string, it does not find it. Now I change this match to search, then it's gonna find things that are ending with .edu. So a match only looks for the first occurrence if it founds on the first occurrence. But a search, it does not matter where you find it. So if I'm looking for something with from here, it will find it, and then a search. A search could be finding your string, the pattern inside the content of a file, at the end or at the beginning, doesn't matter, it will find it like it did here. So if I run this one now, and then you can see the from is matching everywhere. And then right here is in the middle, here is there, but the search will find it. But the match has to be at the first of them. So that is the difference between them. Let's go back to example 2. This one we're using the find all. Find all is going to find as many occurrences of the search that it is there, and that's going to just basically list them all. So if I look for this one, this is like similar to search, and that is there. But notice that the difference between find all and search will look inside here, but find all will look only if they're showing at the beginning. So if I just change this string to .edu, let's say, and then run it, and then .edu at the end of it, it matched. So find all will match also those ones as well. Whatever match is found for the extension. Whether .edu is at the beginning or the front, .edu doesn't care. So let me put that one back to Encore. Encore meaning that it has to start with this one first. So your pattern, what a regular expression does in this case, your pattern, whatever you define is a regular expression syntax. You put that regular expression syntax here, and then you put it inside your method as a first parameter, and then the second parameter is the string that you're searching in the file, in this case, the line that you're searching for. And then if it found, you print that line. You can also assign this one to a variable and then work on that variable later. Let me save this one, save it, and we run it already. So the output is finding all the character that start with from word as a string. And then I could put the column here. If there was no column, it could display it in the same thing. So let me save it and run it. It still worked the same way because I want to make sure I'm consistent with this aligning there as an example. So before I go to example 3, do you have any question?
Hi, Professor. I had a quick question.
Okay.
Do we have an assignment this week? I haven't seen anything in my to-do list on Canvas.
No, I did not have any assignment this week because we just finished the final and then, midterm. And I extended the midterm because of that issue with 12 submission versus 1. Some of you, a couple of students, not everyone, some of you that wanted to take more time, I open it up until the end of tonight or maybe the end of this weekend, depending on which class it was. So you are welcome to submit it and then make sure that if you have not submitted yet, make sure you submit it at least by email if you cannot submit it online because maybe that module page that was for that quiz, it does not allow you anymore for whatever reason. So you can submit it through email by as long as you submit it by this weekend, you will get full credit for whatever you deserve on the assignment. But you will be having another assignment after this week, which will be due next week. So sometime this week, I will assign one for regular expression. You could do, once you learn how to do regular expression, then I'll assign one for regular expression. But it will not be due right away. Most likely, I will schedule it and then give you enough time to just read the materials and go through this class. If you are missed from the list of 3 or 4 people that are not here today, you can still follow this videos and module that I'm going to post later. Once you have those ones, you should be easily writing that assignment or finishing that assignment. So I will have an assignment for maybe next Thursday due or next of a week from Saturday, because what's going on, there's also voting. You may have to go voting, so I want to give you time, but and the assignment will be on regular expression.
Okay,
Thank
great.
you for asking that question. Any other question? And then one other thing that when I'm talking about the assignment and midterms, since you just finished the midterm, there's a lot of reading on this chapter, and the previous chapters that we have covered. There's a lot of materials that if you have not finished them, you're welcome to read those ones and continue working on those ones. But these chapters, I'm giving a look at these examples of 1 through 14, and then 4 more here, 18 different examples. It's good for you to practice them as well. So if I just finish sometime tonight, I'll give you some time at the lab time so you can practice with these ones. And then if you have any question, I'm available till 11:40, including the office hours. So you are welcome to ask any question related to this subject and then our previous chapters that we covered. But the PDF files that I have here is going to give you enough reading there as well. And then all these ones, you can open it up on a Pycharm or whatever method you use interactively, or Adams, you are welcome to do that one. I'm not sure if any of you guys installed Jupyter Notebook, or if you're interested, I could dedicate a session to show you as well on that one. And then with VirtualBox and Linux things, I'm going to show you some commands with grep and other stuff, egrep and awk and set and other stuff for regular expression related things, because once you learn it, regular expression, it will be available for you and your resources in the background at any time with all programming languages. So this example assignment, regular expression 3, is going to have a pattern that is larger. Notice that I created the pattern. You can just create more variables and then more patterns to practice and then do this one. So like, for example, on this one, I'm looking for anything that has a .org in the search, and then do this one. Once I use the with statement, basically, I could use the same kind of things. And then all I have to do is inside my methods, I could do different methods. I could do split, I can do find all, I could do match, I could do substitute, or whatever I want to do. It's all those ones are available. So in this case, for example, 3, I'm looking for the org there. So let me run it there. And then this one is find all is not defined. It is defined, but it does not see somehow. Let me close these other ones. That's an Adam kind of issue. Last time we noticed that was happening. So I'm going to do a save because find all is a method with regular expression. So it should not say it is not defined, because with it, that is undefined already. Regular expression is not defined. Import a regular expression. So let's see why this one is now saying this is not defined. So I'm going to go on the top of this and right here and then save it. It should not say that it's not defined. And then I'm going to open it again and stay here and run it. So now it runs, but it does not give me an output. Again, this is an issue with Adams. So I'm going to open up, let's see, sorry. I'm going to run the code here. That was example 3, and it does work. And then more of regular expression. underscore 3.py. It does do the .org. I'm going to close Adams. I'm tired of just getting misleading information that this is not defined when the interpreter itself is not working properly. So I'm going to use the real IDE integrated development environment Pycharm, in this case, Pycharm. So I open Pycharm. While I open Pycharm, I could and just post these ones into my directory of Python here, clear screen, to test it on Unix as well. So what is the directory here? Python, and then let's just make a directory here, call it chapter 11, make dir chapter 11. I'll call it like that, chapter 11. Actually not chapter 11, rmdir. So I'm going to delete that chapter 11 here by rmdir here. And then since I have a lot of the .py already here, I'm going to say make a directory here under Python, and what I have here under CIS 012. So I want to just put my CIS 012 course, all the documentation of this chapters under lectures. So here is a lot of these ones, but I want to post all of that one on my Unix machine as well. So like we could try those ones, and then I could do everything with the chapters. So just putting all the chapters here, directory of chapters star will just basically list all the chapters. And then star chapters will give you more. What is the 11? Python. Oh, this one is renamed wrong. So let me remove this one to chapter 11. Chapter dash 11 dash regular expression. So this one, it says cannot move because the process is opened by another tool. So what I could do is just make sure that that process, whatever is using it here, is not using it. Let me see if I'm using it here. Yeah, right here I am using it. So I want to close this one also. I don't need it. This one, I'm going to do that move. The move is correctly done. Now, if I say directory start chapter, you should see chapter 1 through 11. So this one, I'm going to do a scopy minus R. This scopy is a secure shell command, secure copy. That's what it stands for. SSH secure shell has a list of commands. One of them is scopy, SFTP, secure FTP, SSH, secure shell. Those are commands that you can do to work between two different machines by making these files as my source file. So -R means recursively. I could say recursively put all the files with chapter this to this machine under the Python directory. I would put it all under the Python, that's okay. But I could also put it outside of this one under the Python and leave the Python as a separate directory here. So if I just do this, and there's no directory called lectures, and then lectures. So let me, yeah, I actually have to create a directory here because I don't want it to get confused there. So I'm going to call it, make a directory here called CIS file, make dir CIS dash Let's just make it uppercase. Make dir CIS dash 012 dash fall fall, and then 2020. And then this one is there. Now cd to this directory. It is basically empty. So if I just copy everything to this directory, and then say is copy with my user ID wlutfi at my IP address 192.168.254.10 colon this. Now this path that I want to put it in this directory with dot. So what is this command that does is a secure shell command called scopy, secure copy. And secure copy is when you install the secure SSH or bitwise operator, bitwise apps or software, then the client will also have these tools available for you. SSH is one of them that I just opened this bitwise session, that right here, I connected, and now on this directory, I have nothing here. So if I look at this one, it's empty. I want to just put all of the files here from doing source copy -r recursively, everything with chapters. The rest of them, I don't want to put it there. So I could just do this and then type in my password. Notice how fast that is going to send it. If chapter, I mistyped it something, directory chapter. That should work.
Does chapter have to be capitalized?
No, because it's a Windows, but because scopy install writes it on the Unix, it may have to. Let me try with uppercase. If it doesn't find it with this, and then the problem is because the wildcard with this copy, it is taking the quotation around it. In this case, it was looking, oh, you want to put it on the Unix machine, then you have to do it case sensitivity, which was capitalized. You're right. So normally, if you put it between a Windows machine and a Unix machine, the case sensitivity is important. Otherwise, the command is by default on Windows, convert everything to uppercase. It does. Since SCP is a different client, it is not just a Windows kind of command, so you have to use the uppercase there. We could have just also, if sometimes you have to do, if it is spaces, you have to do this within the code. And then sometimes if you just do without the -r, you have to exactly specify what is the file that you want to do with a source, and then it will just do that one. So like if I'm doing the virtual environment, this one is lowercase, it doesn't matter, it's going to find it. But normally if I look at the CHP on Windows, see this is doesn't matter, the lowercase, uppercase. But if I'm doing a scopy is an outside external command. So it says, oh, you're putting it on the Unix machine, it has to capitalize it. And you were right. So that worked. And then now it shows it here. And then all of that directories, as you can see, because of the -r recursively, it automatically just puts it in uppercase. I mean, all the directory recursively, subdirectories as well. So if I go to chapter 11 directory here, all the files are for chapter 11 there. But here's the problem. Sometimes when you're putting a file from Windows to Unix, that is copy, the way the echo is working, echo line feed characters instead of /n, the Unix /n. On Windows is /r and / carriage return. so slash or slash v slash. There's a combination of them. So on Windows, if it just translate this one from a UNIX machine to a Control M character, like this. Control V, Control M, like this character. So in order to generate a Control M character, you have to type in on your keyboard Control V followed by a Control M. If you want to just do a tab, you have to do Control V and then Control Tab. That will generate that one. So the keyboard, any character that you want to do a spatial meaning to it, you have to do that. So what I'm showing you here, for example, if I want to open up that example 3 Python script here, which was a problem, notice that Control M characters are all there. So if I just run this script right here, right now, and say run it, first it's not going to run regular expression _.3. It's not going to run because the permission denied. If you look at all these files with the Python, none of them has the executable permissions. So the owner is W-Lutfi, the group is W-Lutfi, and other people have read and write, permission only, not write, but only the owner has read and write and not execute, and then the group also. So in order for me to make all these .py script there executable, that way I could run them. If I run like a regular expression, expression_1.py is going to say permission denied, 2.py, any one of them that I run is not going to do. So I could do it many ways. I could do change mode, U+X. U+X means user has the honor to do that one. Regular expression 1.py. Now I convert that one to do this one. So now if I run this one, it just run it, but then it says this Control M characters, bad interpreter. The script, it has those Control M character. So now if I just do ls -l regular expression _1.py, now you see that it's executable the set. I could change all of them in one shot by doing 755 star.py and then clear screen ls -l star.py. All of them are now executable. Now you see the color also changed, but all of them has the same problem as the Control M characters. So I have to fix the Control M characters. In order to do one of them, for example, let's say regular expression _1.py, I can come in here and manually do one by one like this and then just do it. But that's very tedious, right? So in order for me to do it with set and awk in programming language and with regular expression, this is my chance to modify it there with programs, writing it once and then manipulate it there many times. Let me see if last time I did this one for, I think I wrote a script already. So Python, tor.sh, test1.sh. No, that's not the one. Okay, so I will write one right now. So I'm going to go back to the directory, and here is CIS 12, and then clear screen, go to chapter 11, and look at all those files and there. I want to modify one of them with a regular expression command inside that operating system here, and then run it, and you will see that it works for one. Then we could write a script to do for all of them. So here, regular expression star, I run regular expression 1.py. It says Control M character is not found, bad interpreter, and I'm going to do this. First, modify the bad interpreter issue. So I go regular expression _1.py. Since this is not a Windows, I'm going to do shebang And then I'm going to change this one to user ben env Python 3. So that line, the first line that I did, had a -1 regular expression underscore 1.py. It only shows me the first line when you do head -1. So if I just type in this one on the command line, this will just drop me to Python 3, and it didn't. So let me see on this one, Python 3 is there, yes. And then which Python 3, so user ben env Python 3. Okay, this would run, but shebang is inside my code. That's why it did not. If I do this one, it will drop me there, but the shebang things is inside my Python script. The head -1, and this one is saying inside my Python. This is a kind of a command to the Python language saying that, oh, you want to run user env and then run Python 3. So now if I run the regular expression underscore 1.py, it did work with the control M characters. Control M characters were ignored because the interpreter was the only issue. But I could modify the control character as well here by doing this substitution. So now I look for the control M character. The way you do it is say escape, and then you say 1 comma $. I put escape and then shift colon, so I get into the command line to just say command interpreter of VI, and then at this time I say 1 comma $, meaning from line 1 to the end, substitute what string I want to substitute. So this one is now as a regular expression kind of syntax, control V, control M. That's the string that I want to replace to nothing, and then that, so start with this string, ending with the last string. G means globally. So now I've modified all of them there, and then I could save it. If I run it now, it's going to work the same way that it worked before. So control the second one, if I want to do modify all of them, I could modify the second one also there. Now let's see if we can modify everything when inside the first line. So pound bank this. I could say ls minus l star dot py. That's the one. In this case, for more head of expression regular expression underscore 2.py. Notice the first line is the one that I want to change that one, because if I run it regular expression underscore 2.py, it still has a bad interpreter. Bad interpreter because this syntax is for Windows. That is on Windows operating system. You could everything but star py more. So I could run Python and then a regular expression 2 underscore py, regular expression underscore 2.py. That would work, and 3 would work because inside of each one of them, that first line is accurate, because this one is saying find the Python interpreter, almost like typing Python here. That would drop me to Python. So since I'm on that directory, it's actually loading all the .py scripts, and then it will just do that. So let me get out here and then run here. So this one, I want to just modify this file to regular expression underscore 2. How do I do that? One is easy. So I could VI it and just change it, or I could do programmatically. So let's do it programmatically. First, we want to do a star.py. This will just generate a list of them. Now I want to do a piping, and then say that show me only the lines that are field number 9. This is field 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the files are print $9. This is again as regular expressions within the set or awk programming. So now I'm getting this list of those ones. So if I just want to go on each line and then say while read var do, and now I say ls minus ld $var, I could get a list of all of them one by one like this. But instead of getting a ls minus ld this, I could say while read var and do, and this time I'm going to say echo working on $var. And then at this time, we're working on the first one, which is copy. So we want to do this copy $var, whatever is the name of these files, we want to duplicate it as a backup. So I'm going to say $var underscore back. So I want to just keep the same one, but I want to just distinguish this variable. So in Unix, and if you want to make it sure that it doesn't misunderstand it, you use this braces around the variable, and that even if there's another character, like in this case underscore back, this is saying the file name and underscore back. So if the file name is copy.py, it will be say copy.py underscore back, and then my print.py.back. So by doing this copy, we're duplicating the work. So in case if we made a mistake, we just restore it back from the underscore back to the original one. So this is a safety for you not to make mistakes on something that you want to do. In this case, I want to do set minus E and then substitute what I want to substitute. In this case, I want to substitute, I want to use this symbol or that symbol. Once I use that symbol, I have to be consistent with it. So I'm going to use this shebang and then space Python. I want to change that line to shebang shebang pound. Sorry about that. Let me make sure that this is off. Okay. Shebang Python shebang. Okay, now we want to do user ben env and then Python 3. So this is what we did to substitute that Python from that to this, and then we did that globally. But now we have to close this substitute command, and then we say from what file, from $var, and we want to send it to a file that has something like $var, and we want to create an underscore temp. So do a $temp that is available here. And then at this time, it is, sorry. Yeah, so that is, why did it execute that one? It should have not executed for some reason. Set minus C, substitute this to $var greater sign temp. It actually substitute this that okay, so this set is showing, yeah, that's fine. It should not show the output here. It should be like this, command and that command, and then later on the output will be written there. And then now I'm going to do copy $var underscore $var underscore temp to $var. We want to just override the $var with it because we made a backup. It might mess up this one, but I could just do this. And another thing you could do is just to say this, you could Control C out of this and then copy this one and just put it into a script. So we could reuse it every time and we could modify it after. But let's say I'm writing here, I'm going to say vi update.sh. And then I just put this line, but get rid of all these lines here. So I get rid of all of this. And then here I'm going to put shebang user ben env bash. So and this script is a bash script, but all these lines that does not mean anything. So I'm going to substitute all the $, greater sign symbol. In this case, I'm sorry, the greater sign symbol with a space to nothing. So that way I could do it programmatically. And now I do ls minus l star.py awk print $var read var echo, working on $var, copy $back, set minus s, substitute this one, and then right here, see the greater sign symbol was not copied somehow. So I'm going to do that one, this, and then substitute this line, I don't need it. And then copy, I need it. So this is script and there. And then let's just clear the screen and then cat update.sh. And notice that update.sh is not executable. So if I do that update.sh, it's not going to run. But if I do a bash -x update.sh, -x is saying that open a bash executable and I must say, I'm sorry, bash interpreter, and then run it and execute this update.sh script. This will do it. But I want to just do it with change mode with 755 bash update.sh. Now let's -l update.sh is there, and I could do this way. So now it did working on this one and working on that one. It did work, but let's see if now I have .back, sorry, star._back. I have those ones. I don't have anything with temp because I moved the temp. Actually, I copied it rather than doing the temp. So I have multiple copy of it. But what I could do is remove all the temp there. So cat update.sh. If I had done a move instead of the CP, then the temp would not exist. But let me verify first to make sure that .py scripts are good with it. So more of regular expression _3.py was one of them. And notice that it already updated there. And then the same thing with 4 is good, and with 5 is there, and there is good. So that said, updated everything for us. But the control M characters, we did not modify them and there. We could also modify it with control M characters, and then a star.sh here would have done the trick here as well. But let me just see. First, I want to do this star.back_back. We have the .back and we have the .temp. I'm going to remove a star_temp first, so we don't have too many files there. And then the star.back, we could remove it as well. And then let me just do this one, rm star_back. We don't need it. And then here we have those regular one. So if I run regular expression 1.py, it will run, 2 would run, okay, the 2 has something with cache return no such file or directory. User Ben env. So let me see what is going on with 2 and 3. Yeah, so something did not work on these ones. So let's see, head of -1 of a regular expression underscore 2.py. So the first one, it has user Ben env, and then this is saying that it's a carriage return at the end of it is rather than a new line. So vi regular expression underscore 3.py control M characters, and then so control M characters are the cause of the problem here. It is not understanding new line characters. If I get rid of the control M characters, 1 comma $, substitute control V control M, and then change it to nothing, and then run this one regular expression .py, that would work. So what we want to do is update our script this time to change all of the one that has control M characters as well. So vi update.sh, and then here, since we did already this set statement, I'm going to comment that one. We're not going to do the same update there, but instead of that one, we want to do substitute, and we want to do control V here, control V, control M, and then substitute it to nothing, get rid of that, and then send it that. So now this time, cat update.sh, this line is commented, which we already took care of it, but we still need to do a backup of the previous one. We still need to overwrite to write this. And instead of doing a copy, I'm going to do a move and this time. So we just don't create this. And then the back, we will delete it afterward when everything is tested there. So store.sh, here update.sh, it ran it, and then now store.sh are good. Store.py should be also good. Now we run regular expression underscore 3.py. It runs. Permission denied is because of the permission. So change mode 755 store.py, and then we run it back. It runs, and then run it on 4. It works, and run on 2. It works. So each one of them was that control M characters. We basically fixed it. And so now you learn how to do set, how to do awk, how to do a VI and modify certain things. And here, like for example, on the grep command, if I look for all the pies, and then I say grep -v regular expression underscore 1. So this is going to show me everything that is not underscore 1. But if I say grep -i, it only show me the one that start with -i. Not this because of aliases. Alias grep, you can see that the auto color is on. So in this case, the color is showing what I was grepping out for, and there. And then if here I want to do this grep command with, let's say I want to just do 0 and 10, it will grep out only that one. But if I want to do this one, say, give me either 0, 1, or 2, or 3. Those ones, then we'll list them, all the ones that are there. But unfortunately, it did not understand the rest. It only matched grep underscore, and then 1 was found. And so and 0 is not highlighted here because that's a second digit. So what I want to do is wildcard that one again. Here I could have just put those ones, say 0 through 3. That would return those ones. But then I want to say also the second digit has to be 0 through 3. Then now it's going to find out and 10, 11, and this. So it is a 2-digit and there. I could have just done this as a wildcard here, and then that would not match, but the plus sign is not matching. So at this time, it looks like it has to be saying 0 or 3, but then a second digit. This will not work either. Let's see if we could do plus. Yeah. So the only way it would work is to say 0 through D, 0 through 3 a second time to match out those digits. If I'm looking for 13 only, then I could just say 3 here and then 1 here. That would match those 13 here. Or I could do something like within this, I could do specifically 13 if I want to do that one. Or I could do, for example, for 13, what other method you could pick up? You could only say grep 13. It will also find out everything that has 13 there. And matching of this digit, so you could say, if it is a digit, let's say, find it. Now, this is searching for a letter D because we're skipping it and the letter D here. Let's see if we, yeah, this is basically because once you use the bracket here, inside this one is different than Python searching. So here, if I'm looking for a word, it's not doing that one with the word. It's doing it basically with the W. Wherever there's W, it will search that one. If I put this one in this single code, this is still kind of like finding wherever that character is. But inside your Pycharm, Python, it will be different. So let's say regular expression underscore 4.py, and then more regular expression underscore 4.py. You can see that this one is basically looking from on the search for the starting character with F, and so this is there, then followed by any 2-digit. It doesn't matter what the 2-digit is. So it will just do that one. But the first character has to be F there. Let's just see if Pycharm opens it. I could just open the example that was giving a hard time in Adams. No, this is, I have to go chapter 11. So on this one, example, this one was a problem with Adam. It was saying regular expression was not found. And I decided to go to the IDE, this. So let's say we want to run a regular expression. And then this one it runs fine and it gives you output here. Basically, it finds the regular expression. But Adam was saying that I do not understand regular expression. I do not understand find all. If I just open Adam again, it's going to come up. But somehow the buffer is not clearing some of the dirty read and dirty write that it is doing on the cache. In a database, sometimes when your cache is manipulated with a certain kind of like chunk of data that was read, and then the OS or the memory does not know about it, it is called dirty read and dirty write. So you cannot trust it because maybe one person is working on a set of database tables, maybe they're manipulating a granularity of certain object, and they might be having a lock on a table. Maybe 10 fields are modified. While they're modifying it, you're reading for a select statement. But while you're doing a select statement, you decide to do an update. And then at this time, when you do update, the locking is still established by the other person, so you should not be able to write to the same data that he has already kind of like opened the cursor to read it and then modify it. So that kind of information sometimes by the database, it is managed and controlled, and they mark those data not to be opened by other users. So they call it exclusive locking. And there's locking mechanism that you could do, whether share lock or exclusive lock. And then there's deadlock sometimes that some process they both are fighting for the same kind of memory resource or same kind of object that they're accessing it. And since they're both waiting for the same object to be open at the same time, while one is reading and another one is also reading, and then nobody is updating it, sometimes the deadlock happens, and unless one is just doing it. And then normally operating system and database, they try to control that one, and then on behalf of the user, one is committed and the other one is rolled back or something in order to just get rid of the deadlocks. So in this situation with Adams, if I just go open up again, it should be okay. And I could run it there. And so just as a test, let's just go back here and we call it Adam. Because the cache or whatever it was, sometimes it is not allowing it to run. Originally, it was saying that regular find all was not defined, and then when I saved it, its regular expression is not there. Even though we imported it, it was not there. And the same program worked from command line and also Pycharm. As you can see, it works here, and then it's not a problem. It should not be a problem on Adam also. So let's see if it first listed somehow. Open file, regular expression, and then we're opening this file. And package run scripts. It was saying regular expression is not found. And then now it works. And then the other thing that's important is this one. You could put it anywhere you want, but it's nicer to put it on the top level. So now it works, the Adam that was complaining earlier about the regular expression. It was something with the cache. And you can see that something that works differently using on different tools. And then you know that, oh, okay, this tool may be having some problem with memory content at this time. So what you could do here as excuse me for 1 second. I need to open the door. Somebody is on the back. 1 second. Sorry about that. So if you look at the script, it works. And now I want to just modify this one. Let's see if on the Pycharm it looks nicer. Yeah, and in Pycharm I like it. So I'm going to modify it inside Pycharm. So in this time I'm going to run it with the pattern as pasadena.edu. Save it, and then since this is Pycharm automatically saved, I don't need to save it. I'm going to run the same code this time with it's going to look for pasadena.edu. And then you can see that it finds out pasadena.edu, a student, and so on. Here, if I just want to do this other search pattern let's say search for this one. Let me explain that one. So this one is opening up the information, but it is doing a lot of different ways of regular expression. In this case, this backslash s plus means any non-white space. So plus means one or more occurrence of that one. And then this class with the bracket here means either 1 or 2 or 3. So since it is 1 here is found, then that's a match. A 2 is match. A 3 is match. So if it finds the first one, then it's going to find that list. And then after that one, star meaning that I could have as many of these numbers. 1 could be repeated 10 times, or 2 could be repeated 10 times, doesn't matter. Or 3 could be repeated. So star means 0 or more of that occurrence. If it's only 1 digit and then followed by nothing, that's fine. If it's a second digit is there, it's fine. Then it's followed by the @ symbol. The @ symbol, notice it's not escaped here. So the @ symbol is not a meta character within the regular expression of Python. So you could just type in a @ character, it will know. And then followed by an I. So this one before the last character is an I, and then a non-white space again. So as long as this one and anything that's not white space, then it's gonna find it. So it's gonna find that information here. So let me open the next one, which is Pycharm 4. And then this one, no, I'm sorry. I opened a different one under, I want to close this, and chapter 11. Chapter 11, this is example 4. So this one is the example, we already ran it on the Linux machine. We will just run it here as well to make sure that it gives the same output. So it should give you the same output. It's saying that anything that is started with a F uppercase and then followed by any 2 digit and followed by M. So this is matching, and then that will present that one. And then under the 5, this one is saying that and dot plus @ symbol. So let's see, run this one, run. Okay, so after this one, I'm going to go back to Linux and run these ones faster, because I want to save some time for you guys to practice as well. So here, this one is there. And let me go back to the Linux machine. We already did it, clear screen. And then ls-lstar.py. So now cat, so if I want to just run all of them in one by one, I could do this one. Or I could say, for example, for I in, say number 5, 6, 7, 8, 9, and then let's say up to that one. Let's see, sorry, for I and this one. Actually, I don't need a for statement here. I could do ls-lstar underscore the digit 5. The digit 5 dot star dot. So I could do one character 0 through 9, and then I could put one question mark dot py, and that would list me everything that are there. And then I could say for all of those ones, if I want to run them, I could say while read var do, do a cat minus n $var. First, say something like echo now running the script $var. And then after you do that, when you say cat minus n $var, so it will display it and then run the script with $var. And then you could say, for example, echo the output is shown below. And then do a new line characters, couple of them, and then say $$ $var. So you could do this and then say done. This will just run each one of your script, and then invalid option carriage return cat minus n. I did that right. Minus n. It was not working with $var. So let me see what is going on here. List minus l.py cat regular expression underscore 4.py. We did that one, and then 5.py, and we are on 6. So on 6, we could do that one, and then regular expression 6.py. It did run it, and it's there. So let me see what happened on my cat statement. This one, while read var. Oh, that's why cat minus n. It did take the semicolon, but it did not understood the cat minus n. So I'm going to do cat $var, cat invalid option dash dash. There's no dash dash. I don't have any dash dash, but it is not reading it. So let's see if I could do this. Copy update.sh to test one.sh. vi test one.sh. So I'm going to change star.py here, working on, and then don't do this, and don't do this, don't do this. Okay, so I get this one. Oh, yeah. Sorry. What I made a mistake here. I did it on the carriage return. So here I didn't parse it to this while read var. So far it's not having the file name. I want to look at the file name awk, this print and $9, and then that would produce it. So that's why, well, I didn't filter that part. So cat minus n should work. Where's the cat? And then cat minus n should work. So now it works the way we want to do it. And I want to just go through the example and show you what I did here. So whenever you're doing it on Linux versus a Windows machine, now you have more power to do it programmatically. If I want to run all the Python script here, and notice that I did this one saying star.?pi, I could replace that one with star.py and run all of them. Then it says awk print $9 now, and instead of dash r that was showing with the cat, because if you don't do it, it reads the each line there. By doing this statement awk print $9, you're gripping out the list of the file name. And then you put that into the variable. Now you work on each variable. So it says now working on the script 1, and it cats it with the new line characters. And then on line number 11, we have the line is strive, and 12, we have the search. So, and then the output is showing below. And then this one did not work because I had to do echo minus n. So clear the screen. If I go back to my statement here, where I have the echo statement, I have to do minus e for a regular expression. And then now the slash new line is understood. And then right here, minus e also for new line characters. So, and then in this case, I want to just do a regular expression star. Regular expression star. That means every regular expression statement that is there, it will do that one. So as you can see, the script that it does, for example, on the first one is regular expression.py. It prints actually, and this one regular expression.py, because we say help on that one. Help regular expression, it prints out a regular expression output here. You can see on Linux also, it works the same way that it works on Windows. So it does give you that output. And if I just go down here on that second program, and then it says echo working on, so this is still on the first program, regular expression output. And then once that one, the module, this is all the list of the methods that are available with regular expression. The regular expression will give you all that one. Find all and then match and everything else is there. Find iteration and search is there. All of those ones, split is there. So here you can see that it's working now, working on script search. And then script search is basically searching for a string. In this case, I'm just giving you the syntax. It says search for a match. For example, it has a pattern and a string. Match has pattern, a string, and then flags. And then the flag by default is 0. Otherwise, you could have the flags to ignore case or something, or ASCII or locale or something. So this is for Python 3, and then I'm sorry, regular expression for search, and then it goes through in that order, and then it runs the output of the search. This is the second one. So notice this one, we're searching for this. This could be uppercase T or lowercase t, but it has to be followed by HIS. So in this case, it found that this here with the search. So this is how easy it is. When you find it on the my match here, this my match is an object of regular strings class search of regular string search. But then this this word was happening on the index of 0 and 4. So when I did that one, notice I printed out the end of it and the starting of it. The starting was 0 and ending with the 4. And you could also do the string of that one to print out the same start and end by doing a string of string 1, which was the actual word, and getting the index of it from the match. The start and end will just print the actual string. You could also do the dot group of this one. So let me show you this one on the, what the example is this one. This one is a search. Yeah, Python search. So let me show you that one in Pycharm, or the other one, doesn't matter. One of them is gonna work on, this one is better. So I'm gonna do the Pycharm example of search. This is very important to notice because we're using this one as a grouping options. So search, so the way this search works is going to look for a string, but notice that when I'm looking for the pattern, this is the string that I'm putting it with a new line character. So there's one this here, one this here. The first one is start with uppercase. The second one on the second line is printing with the lowercase. So let me run this one first. Run it. expression search. So as you can see, this one, this is the string that is going to print it first, and right here is the output starting here. A string 1 is, and then I say string 1, and then a string. This is the first line. Because of I have a new line character, as you know, a string, it puts this is a second one on the second line because of the new line character. But then I have a pattern here called uppercase T within the class, and then lowercase t. With the bracket, between the bracket, this is not a list. This is a pattern and that you want to match as a regular expression. But this uppercase T or lowercase t, whichever one of them has happened, then it has to be followed by HIS. So whether it's uppercase this or lowercase t with this, it will match both of them in this case. This pattern is searched. So now on the string 1, this pattern is found, and then this one, it prints the type of it, which is, and notice that this is not a string as an output. It is the type of it is a class of a regular expression match. But the actual output is showing that as my match, which was put into here, my match is having this regular expression match object, and then a span. A span is like a start and end of it. So there's a dot span of this method that the search that is coming. When for this object of my match, if I do a dir of this object, my matched, notice by doing this one a dir, you will see that there's group, a span, a start, and everything else is available for it. For find all output, it is not there. The grouping is not there. So for each object, different method and different properties come into play dynamically based on the object itself. So if I run it now, the reason I'm doing this dir to show you what are the methods that are available here. And notice that here, and these are methods. So groups is there, group is there, end is there, start is there, span is there. All of those ones are available here. You can see span. The span is giving you start and the end of it. So here I used the end and the start method, which was giving me the output of 0 and 4. Let me just comment this line out because that's giving me more output than I need, where I see type of this one. A directory of it. Where did I write directory? All right. Lost the directory. Right here. So on line 17. So this one, I'm going to comment it out and then run it again. Now I have a shorter information, but it's good because I want to show you some of the method that we just looked at the directory that are available. So by knowing that and there's a method for that my match, whatever was my match there, I could do a start and end, and then I printed out and that one. So notice that this time I printed the whole thing because of these. This one was matching more characters on that string. So if I just do the search differently, I could find this. Now I could do, for my first example, where I said my match is there, I'm going to do, rather than start and end, I could print it out. And instead of this, I could say print, and then my matched dot group. So this would print out that match, and then here I could print the start and then find. That's fine. Here I could also do another one. I could say print my matched dot span, okay, and then span, this is a method, so my matched dot span, and then print my matched dot start, and that's a start method for it, and then print my matched dot end. Let's say I want to just see this one. So this start would give me 0, end would give me 4, span would give me this, and then also group will give me this. And this span will give me 0 and 4. So now I could do this and say print run it. For the first one that was showing this, so let me go back to this right here. Since I'm doing the print match start end, 0, 4 was showing here. And then I say group, this is printed here. Before the group, it was in this kind of object, a rematch, and when I printed it. So if I do this one will print it like this. You will not get it because it says it starts at the index of 0 and then finish at 4. I could have printed like that also to do it with the string, or I could have done it with the match.group and then take that this out of it. And then the same thing here. So group is going to give me this. Span is going to give me 0 and 4 as a tuple. And then start with 0 and 4, and then start is 0 and then end is 4. That would do this. So now this, copy this line here and then go to the end of this one. Let's say I want to do the same thing here for the last word, and that was these. Notice that if I run it, this is the first test. It will be printed twice, one time because I did it here, and then one time because of the group. The group is a shorter form of the same thing that I printed that one. So this is the first test was printing here as this, a string of that, and then the group printed this line, and then the span printed 0 and 46 because it start with 0 and 46, and then right after that one, the start and end, the start is 0 and 46 lines altogether, 46 characters there. What time is it? 9:44. 10:30. Okay. So I've been talking forever. Sorry about that. And there's other ones that you could also look at for the examples that I want to do. I want to give you some time to practice and these ones on your own and ask questions. At this time, I'm going to stop lecturing, and I want to just or demo the part that I wanted to do. As you can see on this examples, there's a lot more than just 10 or 14 examples. So some of them I run it here, but you have to go through them because I have it on the canvas under the documentation. So you can look at them and compare them and everything. And each one of them, as you can see, for different purpose, I wrote it in different methods. Like this one is split. It splits it on a new line characters. You could see that one. Do you have any question before I stop? Okay, if you don't have any question, please use the rest of the time in office hours to ask question or work on the lab activity. So let's work on maybe the split function by yourself to see what you can do with the split. So here, the split function is there. There's two of them. If I run cat regular expression underscore split dot py, is this a script? It's a little bit long, but you can practice with it in the time that is left. So if I run it, it's just basically doing it. And then as you can see, the line that was there originally on the script, let me see what is my text, grep -i my text. So my text, as you can see, is after this one is a split. What was the original string? Let me do this and then, okay, text. So if I just look at the grep as text, the first string, it says is a string with 3 lines. This is line 1, and then followed by a new line. This is line 2, and this is for. So when you print the line and text, it will print it in 3 lines. But originally the string is in a raw format. That's what it is. So if you run the script on this one, notice that the first line was saying this is the 3 lines. It prints up in that 3 lines format when we print it with a pattern. And now the pattern is saying that a backslash and dot. And then you want to just search for that pattern on that string. It will find out that pattern into a list because we are searching it with the split method. So it splits it by those ones. Then I put that line element by element. Each element we're printing it as 1 because I split with the dot as a regular expression, the pattern that we do, that dot or gone here. See here, there's dot here, dot here, then here, because we split it by that one, there's no more dot here when we print it. But if we want to just duplicate the scenario and print it, and then the statement that I was using, the for statement, it went through them and added a dot here at the end of it. So now the problem is because the list itself had a new line character at the end of it, or a space. In this case, it puts a dot at the end of it too. But then I didn't want that dot to be at the end of it like this. So what I did was wrote this example 1.py. Now it is converted to dots, and then at the same time on this example it is just generating it, so there's no new line characters, and then this one does a word count on the lines here. So let me show you the split.py cat minus n. So notice that this one is a regular expression imported. This is the line with dots at the end of each line, before the end of each line, and the pattern is a dot. Yet when we do the comparison here, the string that we are matching, when we print it with a dot, it will just print the output with a dot, but then there's a single character, extra character at my end of my list, which was, I was showing you here with the new line character right there. Sorry, right there. So this one is just not understood, and then there's extra a dot at the end of it. So in order to correct that one, what I did was on the actual script, let me open the actual script right here. What I did here, I created this one, and then created a new text, text empty, and then it says if I, which is the element, is not empty, which is not this in the list, then append it to the new text. Now my text is everything except the extra empty characters. Then I print it, and now it is printing it correctly with the right format. That way, and then it puts a dot at the end of it the way I want to do it. So by running it and this, you can see at the end it just completed with all the dots there. There's other method here that we did .py and the split.search. Let me see. This one is a difference between the two. So find all and then a match. the difference. One of them is matching the first occurrence, and the other one is finding anywhere the same occurrence. And then we talked about the search, that it also search everywhere. Okay, let's work on the rest of the time that is left on these examples, please. And then let me know if you have any question. Okay, I'll stop recording for now. And then you're welcome to ask question for the lab or homework, anything you want. So let me stop sharing also. And then stop recording. I'm available till 11:40, so please ask me any question you have. Thanks.